All right, welcome to day 5, which is going to be on tangent lines. I'm going to ask you guys to go ahead and pause, fill in the notes here and the definitions out of your paper, and then when you get down to the bottom, just go ahead and play, and we'll go through and talk about the examples and draw some pictures here. All right, now that you've got the words copied down here. So the first example is a circle. So obviously we have a single point, which is our center point, which is always, we name a circle by the center. So this would be circle C. And then there's some radius R, and all the points that are the distance R away from the center point create the circle. All right. The radius, once again, is the segment that connects the center point to a point on the circle. And any radii that you draw are always going to be equal in a circle, so keep that in mind. The diameter is any segment that connects 2 points on the circle, but it also has to pass through the center of the circle. Okay? And it created by two radii that make a straight line as well. All right, we'll continue on here. So go ahead once again and pause, fill in the notes, and then we'll come back. Okay, so a chord is, once again, is a segment that connects any 2 points on the circle. So if you have 2 points on the circle and we connect them with a line, that is going to be a chord. A chord can also be a diameter because it just connects 2 points in the circle, happens to go through the center. And then one thing we'll talk about a little bit later on is as you get further away from the center, the chords are going to get smaller and smaller. Close to the center, get larger and larger. All right. A tangent line is a line segment that touches a circle at only one point, and it's usually drawn outside the circle. So it could be a line, it could be a segment, but it only intersects the circle at one point, and that point is actually called the point of tangency. A secant line is a line segment that cuts through 2 points on the circle. So it's going to be a line, all right, and it's going to intersect at 2 points instead of just at one. Next, a semicircle. So you just start by drawing yourself a diameter here, and then you're just going to draw the top half or bottom half of the circle, or whatever half you want, just one half of a circle here. An arc is going to be the distance traveled. It's part of the circumference of the circle. So if we travel around the circle, this would be our arc length, and we've already talked about that previously and calculated that as well. All right. Just got 2, 3 more here. So once again, go ahead and pause, fill in the notes. Okay, the next one is a central angle that is formed by 2 radii. So if this is the center of the circle, the 2 radii that are drawn out from the center are going to create this central angle. We can call that theta if we want, like we've done before. Okay, and then once again, this intercepted arc, we'll talk about this a little bit later, is equal to that angle. But the central angle is the angle formed where the by 2 radii, and the vertex is going to be that center point. An inscribed angle is inside the circle, all the way inside. It's formed by 2 chords. Okay, so 2 chords, and then the vertex is on the circle. And then the thing we'll talk about later is that this angle, if we call this ABC here, is going to be equal to 1/2 of its intercepted arc. And if we call this ECF, then this angle is equal to this arc. And the last one is going to be a radian. So a radian is the distance traveled around the circle that's equal to how many radii or one radius traveled around the circle. So if this is the length of one radius around the circle, this angle being formed is equal to 1 radian. All right, and because we know that the circumference of a circle is 2 pi r, all right, 2 pi r, there are 2 pi radians in a whole circle. So that's what a radian is. And we use radians because they're a lot easier to use in higher level calculations as opposed to like cutting a circle into 360 equal pieces and referring to that as a degree. So radians are a little bit easier to work with, and they involve that letter pi that shows up a lot there. Okay, so for the lesson, two key concepts you're going to need to know. Number one, if a line is tangent to a circle, okay, it creates a right angle between the radius and the tangent line at the point of tangency. So tangent to a circle, the tangent line is perpendicular to the radius. And the second one, we kind of designate in slang terms, so this is not something that'll be written in a book anywhere, as the hat rule. Oh, hold on. This is the hat rule. I'm trying to get the pen to work again. All right, where if you take a circle and you put a party hat on it, both sides of the hat are going to be equal to each other. So that's always referred to as like a hat rule. So if you have two tangent lines, they are equal from the point of the intersection point outside the circle to the point of tangency. So AB is going to equal CB here. So how do we use this information? Take a look at example number one. We want to prove whether or not this line is tangent to the circle. So remember our first thing we talked about here, which was that when the tangent line intersects the circle, it's perpendicular to the radius. So this should form a right angle if it is truly tangent line. And that means that these angles or these segments, right, should be equal if we use the Pythagorean theorem. So is this a right angle? We want to know. We're going to check by using a squared plus b squared equals c squared. Okay, give that a shot. Let's see what you guys can do. Okay, so hopefully after plugging in, 9 squared plus 6 squared is going to be 117, which is not equal to 15 squared because that's 225. So we can say that BC is not tangent to the circle. To circle A, we call it circle A because A is the center point, since triangle ABC is not a right triangle. Okay. All right, let's try the next one. So letter B, we have a hat rule question here, along with points of tangency. So we have two tangent lines from C. So once again, when the tangent line intersects AD, which is the radius, it's going to form a 90-degree angle here at angle D and E. And once again, AE is a radius. So if this is 5, so is AD. And we have two lines of tangency from the same point. So this is like our hat rule. These two lines are going to be equal. So letter A, if segment AC is drawn, what do you know about lengths of CD and CE? And so we can say that CD, that's a B, is congruent to CE. And we'll just put a little explanation, since they are tangent from the same point, all right, outside the circles, from the same point. That's it. Letter B, what do you notice about angles DCA and ECA? DCA and ECA. So these two angles are actually going to be equal to each other. Okay. And the reason is that these triangles are going to be equal, right? These two sides are equal. They both have a right angle. These two sides are equal. We also know that this line is equal to itself. There's a lot going on here, but we can show that the triangles are congruent. And that's why those angles are congruent. And then the reason for that is going to be side angle side. All right. And then what do we notice about lines CD and CE? We want to know our tangent to the circle, find the length of AC. So once again, we can just look at this one right triangle here Let's get rid of that really big line here. And if this is a right triangle, and once again, we can use the side lengths to figure out the hypotenuse there. So 12 squared plus 5 squared is going to equal c squared. So this is 144 plus 25, which is 169. And then take the square root, and you should get 13. So AC is going to equal 13. Okay, we're going to use that same approach here to answer question 2. So why don't you guys look how we did this last question and see if you can handle this one and the next one on your own. So try 2, A and B. Okay, so we have 2 options to solve the first one. Remember, the key thing here is that the radius is perpendicular to the tangent line here. So we have angle L, which is 90, and N, which is 90. So these 4 angles form a quadrilateral, which adds to 360. So we can add all our angles equal 360. Or if you know that these 2 are equal to 90, these 2 angles are going to also have to equal 90. So, sorry, these 2 add to 180. These 2 are going to have to add 180. So you can also solve it using that easier equation there. If you'd like, it's up to you. But this is going to equal 297 when you add those together. And then we're going to get 63 when we subtract from both sides. Why do we put a 6 there? Okay. The same thing is going to happen here for the angle EDO. This is going to also be 90 degrees. So we can add these angles to equal 180, or we know that there's already a 90-degree angle. So x plus 38 is also going to equal 90, and we can solve either way here. So here we're going to x is equal to 128, and then we can subtract 128 away and get our final answer, which is going to be 52 when we're all said and done there. All right, for number 3, we want to find the value of x in the diagrams. All right, let's try these ones. Let's see if we can go on your own, and we'll check those in a minute. Okay, so going through the first one, we have that 90 plus 90 plus x plus 60 is equal to 360. Or we can do 180 minus 60 to get the measure of x, and that should be 120 degrees for this first one. So however you wanted to solve it, that's what we're getting for our answer. For number 2, we have x plus 90 plus 43 is equal to 180. Or if we know that these 2 angles have to make 90 degrees, we can just subtract 90 and 43 and get an answer of 47. For question B. So however you want to do that, it's fine. Question C is a little bit tougher. Hopefully you're noticing that this triangle is the key thing here, is isosceles. And we have a line that is tangent to the circle. So it is going to be perpendicular, but we don't need that necessarily to answer this question. We can get to it other ways, but we're going to keep that in mind here. So there's a 90-degree angle. Now, if this angle is 60 degrees, these 2 sides are equal because they're both radii. That makes this angle 60 degrees, and this is also going to be 60 degrees. So we're looking for this angle x. We know this is 120. If this is 90, this is 30, and then we can get the measure of this angle out here by doing 180 minus the sum of these 2, which is 150, and we'll get 30 degrees. All right. On to number 4. So find the distance length of the tangent line. We're going to want to use just our Pythagorean theorem here. We're going to add these 2 lengths together, and then we have the radius, and then we have d, which is the length of the tangent line there, the segment outside the tangent part. So the circle below has a radius of 6,400 kilometers, and a height that extends is also 5 kilometers. So not really drawn the scale. So that means this whole side is 6,405 kilometers. We want to know the length of d there, so we can just use our Pythagorean theorem. So see if we can try this one, and then we'll come back with an answer. Okay, so starting with our c squared minus b squared formula, since our hypotenuse is 6,405 minus 6,400 squared, and then subtract. We get 64,025. Take the square root. It comes out to about 253, 0.031618. All right, and on to question B. So in the figure below, 3 segments are drawn. If y is equal to 2/3 the length of x, find y and x. Okay, keep in mind here we're going to be using the hat rule. So going back up, remember in the hat rule, these 2 segments are drawn from the same point of tangency, then they are going to be congruent. Now, if we were to pick another point of tangency out here and connect these two from the point of tangency, these 2 segments would also be equal. Okay, so keep in mind you kind of have that going on here, and we could do the same thing from here to here as well. So even if we add more segments on, okay, each of these parts is going to be equal as you go around the circle, the 2 tangent lines from that same point. So we'd have 3 sets of congruent lines, and that's going to be the case on this question. Okay, so try B, and we'll come back and check answers. Okay, so let's start with answers. So you should have got 27, 18 for y, and 21 for z. And to get that, you're going to start with our first equation, which is y is equal to 2/3 x. And then what we can do is we can just take this equation on the right here. Any one of these really doesn't matter. Actually, we do need to use the x and y, and we know that we add x and y together, we get 45. So we're going to start with that equation first. So we can now substitute in the 2/3 x for y, and then I can solve. Now, for me, I want to add these together first, so I'm going to need to get to common denominators. So I need to change this 1x into 3/3x, and now I can add these together to make 5/3 x. A couple options. You can multiply by 3/5 or make a proportion and then cross multiply and get 5x is equal to 135, and then x is 27. So 27 taken away from 45 is 18. That means that's what y is. And then you can either subtract the 48 away from 27 from 48 using our hat rule here to get 21, or 39 minus our 18 to get 21. Either way, you should end up with 27, 18, and 21 for question B. All right, last 2 questions here, and then we'll do this together on Tuesday. What is the length of the radius C? So let's try these 2 for questions. Let's see if you can handle these for homework tonight. You're going to have to, okay, create this entire length by adding these together, and you're going to get a quadratic equation here. So let's see if you can handle this question, and then the same thing here. So x plus 6. Let's just get the start up here. So we know that this is my hypotenuse, so if I start with a squared plus b squared is equal to c squared, and plug in, we're going to get x squared plus 12 squared is equal to x plus 8 squared, which, remember, when we see squared like this, we want to write it twice and distribute. Okay, so do that. Then you're going to get x squared plus 144 is equal to something. Get this equal to 0, and then see if you can factor this out. Okay, and then from here, you're going to take each of these equal to 0 and solve. And you're going to handle this the same way. Okay, so homework tonight, and then we'll see you guys tomorrow. Have a great rest of your night and day.